HHO scammers claim that because hydrogen burns faster than gasoline, it produces more power. Let's examine their bullshit theory. The BMW Hydrogen 7 runs on either gasoline or hydrogen. Here are the specs, directly from BMW. At 100 kilometers per hour, which equals 62 miles per hour, the cruising range is 125 miles, using 17.6 pounds of liquid hydrogen, stored in a super insulated tank at Fahrenheit 423 degrees below zero. BMW says the 19.5 gallon gasoline tank provides a cruising range of 300 miles. Let's examine the amount of energy used with both of these fuels. Here is a table from the United States Department of Energy. The link is in the video description box. The table shows the lower heating value of hydrogen is 51,500 BTU per pound. Using the lower heating value is better because engines cannot benefit from the higher heating value of a fuel, because approximately 38% of the heat goes to the cooling system, 36% to the exhaust, and 6% to the air surrounding the engine. So, the BMW Hydrogen 7 uses 17.6 pounds of hydrogen at 51,500 BTU per pound, or 906,400 BTU to travel 125 miles. Here's a table from the same United States Department of Energy document. It shows that the lower heating value of gasoline is 836,000 BTU per cubic foot. A cubic foot holds 7.480519 gallons. 836,000 divided by 7.480519 means the lower heating value of gasoline is 111,757 BTU per gallon. So the BMW Hydrogen 7 uses 19.5 gallons of gasoline at 111,757 BTU per gallon, or 2,179,261 BTU to travel 300 miles. 300 miles is 2.4 times more distance than 125 miles on hydrogen, so we take the 906,400 BTU to travel 125 miles on hydrogen and multiply it by 2.4. Thus we see that on hydrogen it would take 2,175,360 BTU. Only a 0.1789% difference. So now we can see that whether we use gasoline or hydrogen, it takes the same amount of energy to travel 300 miles, and the HHO scammers are liars. Now that we all understand that hydrogen is not magical, let's examine what it would take to save 10%. At 60 miles per hour for 1 hour at 25 miles per gallon, we consume 2.4 gallons. 2.4 times 111,757 BTU per gallon equals 268,217 BTU. 10% of that is 26,821.7 BTU. This table from the United States Department of Energy says that hydrogen has 270 BTU per cubic foot. HHO is only 2/3 hydrogen, so a cubic foot of HHO would have only 180 BTU. But the Department of Energy figure is at 60 Fahrenheit and sea level. At a more typical 120 Fahrenheit and 200 feet above sea level, the HHO expands because of lower pressure and higher temperature. My calculations show that 161 BTU per cubic foot would be more typical. 26,821.7 BTU, which is our 10% savings goal, divided by 161 BTU equals 166.5944 cubic feet. There are 28.317 liters in a cubic foot, so we need 4,717.45 liters of HHO to save 10% on our 1 hour 60 mile per hour drive. That is 78.624 liters per minute, or 78,624 milliliters per minute. At 6.1 milliliters per minute per watt, which is 86.38% Faraday efficient, we would need 12,889 watts. Most alternators have about 36 amps of reserve capacity times 13.8 volts, which equals 497 watts, which is only 3.86% of what is needed to save 10% on gasoline. So we could expect a 0.386% savings, but we have to consider the alternator. If the alternator was 100% efficient, we might get 0.386% savings, but the typical alternator is 40 to 60% efficient. There is a link in the description for a high efficiency alternator. It says its peak efficiency is 68%, but at a more typical 50% efficiency, we need the engine to input twice as much energy into the alternator as we get out, so that easily wipes out the tiny 0.386% possible gain. HHO is a total scam.